All right, so we've all made a box out of a piece of paper. They're all different sizes. We've agreed that the size of the corners is the determining factor as to what our volume is going to be. So let's take a look at the problem in our notes, number 4. Here's our piece of paper, and they tell me that it is 12 by 15. They have cut out corners, square corners. We have no idea how big they are. Right? What size corners should be cut to yield a box with a volume of 123? So, for some reason, somebody's decided they want this volume to be 125. What are we gonna do? What do you think? Can we write an equation for the volume of the box? What is the volume? What's like the general formula for the volume of the box? Length times width times height. So volume is length times width times height. Okay. So what is our length? Now remember, in the beginning, the length of the paper was 15. But you chopped some stuff off, so now the length is not 15 anymore. What is it? This is the length. What is it? 15 minus 2x. And the width used to be 12, but now it's just this, which is 12 minus 2x. And then the height of the box is x, because isn't the height the corners that you cut out? Isn't this x right here? So there is our volume formula. Now, question A says, we want the volume to be 125. So would you agree with this equation for this problem? Okay, now, you can, if you want, go ahead and FOIL that out, subtract 125 and set it equal to 0. That's absolutely fine. Or we can leave it just like it is, type this in as one equation, type this in with parentheses and all as the other equation, and look for where they cross each other. All right, let's do that. Now, keep in mind, one of your equations is going to be this. So, if you're going to type y equals 125, then your y max has to be up to at least 125, right? Probably higher, like 150 or something. Let's think about this. What about y min? Remember, in your equation, y is the volume. What's the minimum volume you can have? 0. So in my window, I'm going to let my y's go from 0 to about 150. Does that make sense? You guys can type whatever you want in the calculator, but if the window's not set right, you're not going to see what you need to see. So think about y is the volume. Volume can't be negative, and it's got to be at least 125, so I went to 150 just for good measure. All right, let's see what we see. So 125 is 1 equation. We're putting in parentheses, the calculator does not mind. No need to FOIL, just waste time. So, is everybody on board when I say y min is 0 and y max is 150? Is everybody on board with that? What about the x's? Is there a minimum and a maximum x? Remember, X is, I don't know what happened to my corners, but X is the corners that I cut out, right? This is X. Can X be 0? No, because if X was 0, I wouldn't work anything out. How about a maximum X? Is there a maximum X for this problem?
It's 6.
I heard somebody say 6. Who said that? Big Al? Why?
It's because, it's gonna be 12 minus 2x, so it'd be 12 minus 2 times 6, which is 12.
Exactly. Think about your smallest dimension of your paper. It's only 12 inches across. If you're taking a chunk from both sides, can it be bigger than a 6? No. So when you set your window, I think that's a great window. Very logical. And it should show us exactly what we need to see. I see this coming across, which I know is 125. And then I see some kind of, it's not a parabola, it's not symmetric, but it's some kind of a thing. I don't see the very top of it. That looks like that. So I need to find that point and that point, because those are the points where the curve exactly equals 125. Okay, so let's find those. Second calc intersect. I got one X value to be 0.942. Can I have a confirmation? Is that right?
Yeah.
Perfect. And the other one, I got 3.778. So the question was, how big a corner should I cut out so that the volume of the box will be 125? Does it make sense to you that we can either have corners that are 0.942? What would that box look like? That box would be one of these flat ones, like this, tiny little corners cut out. And then we'll cut out bigger ones and have a box that looks like this. Okay, perfect. Okay, next question. Yeah.
Do we need to worry about the part where it goes back up at the end, like the third?
Okay, so Enzo, being Enzo, has his window set somehow, and he has noticed, because his window is much bigger, that this curve, this cubic curve right here, comes down, and then at some point comes back up. So there's another point of intersection out here. Now, if you set your window up the way we kind of determined, you don't see that part, but this is a cube, and a cube is going to have this kind of behavior. All right, we're going to talk about that in a couple days. So when I draw that 125 across, it's actually going to intersect 3 places. Now let's answer Enzo's question. Enzo, since you got it there, would you find that point? What is that X value?
It's 8.78.
So 8.78 something, right?
Yeah.
Tell me about that. Do I need to worry about that one?
No.
No, why not? X can't be 8 in this problem. We determined that the biggest X could be is 6. After that, you can't do it anymore. You can't take 8 and 8 out of 12, right? So the answer is no, I don't have to worry about it. And to avoid confusion, I like to set my window up logically, so I don't need to worry about all that stuff, okay? This, by the way, 0 to 6, that's called the domain of the problem. Those are the possible x values of the problem. Anything beyond that doesn't make sense in this context. Okay? All right, next part of the question says, what size corner should be cut to yield a box with a volume more than 125? Well, more than 125 would be all of this. Right? So that would be more than, would be 942 to 3.778 with parentheses, because more than does not include. What size corners should be cut to yield a box with a volume of, at most, 125? That would be this part of the problem right here. Would you agree with me? And this part of the problem right here. So 0 to 0.942. And actually, I probably shouldn't include 0, should I? Because what happens if x is 0? I can't even do the problem, right? I can't make a box. And then 3.778, comma what? 6, yep. That's the biggest. Couldn't go any further than 6.
Why are those brackets not parentheses?
It says at most. So at most means it can be that much, but not more than that. Okay? Now, while we've got this here, let's find the x that maximizes the volume of our box. So, would you all agree that this is my maximum up here? And when I graphed it, I didn't see that. So what will I have to do if I want to see the top of that box? What should I do? Make y bigger. So I go up to 200. Now I can see it. So the 125 doesn't really matter anymore. Now I am just looking at this equation. So you can take out the 125 if you want, just hit clear, because we don't need that anymore. We are now just looking at the volume equation, and we want to find this point right here. So here we go. Second calc maximum. Set your left bound over here somewhere. Your right bound over here somewhere. And then put it right there at the top. And the x that maximizes the volume is 2.209 inches. So if you want to make the very biggest box possible, you're going to cut out corners that are 2.209 inches. And the maximum volume is 177.234 cubic inches. Because remember, x was the size of the corners and y was the volume. So when they gave me an ordered pair, the x was the size of the corners and the y was the maximum volume. Think about people like, oh, I don't know, whatever company makes Kleenex. Every time they make a box, they have to use cardboard, right? Every box they make uses cardboard. Is it in their best interest to use that cardboard and maximize the volume?
Yeah.
Absolutely, right? People really do this stuff for real. This isn't just made up. They really do this for real. Okay, Any question about that? All right, after class, when you go get your phone, deposit your paper, unless you just want to keep it forever. Deposit your boxes in the recycle, okay? I don't want to find little pieces all over. All right, now we're going to P8. P7 will be due on Monday. And now we're doing P8, which is our last prerequisite before we jump into Unit 1, which is all about functions.
Is that what the P stands for?
Prerequisite, yeah. All right, so solve algebraically. We just did a problem that we solved graphically. We had a volume equation, we had a 125 equation, we backed them and looked where they intersected. Now we want to do the same thing without the calculator. We want to do this graphically. So what's a thought that you have?
Set them equal to each other.
Yeah, we can set them equal to each other. This is called a system of equations. And we normally, if we're doing it by hand, solve systems with either substitution or elimination. So if we are substituting this in for y, we can solve this equation. Okay, so what would be your suggestion to solve that? We're not graphing it, yeah. So we're gonna subtract and get the thing set equal to 0. When in doubt, set your equation equal to 0. Because then you can use the zero product property if you can factor it. This is factor.
Yeah.
Yep, we can take out our GCF. And then we are left with difference of squares, which factors how? X minus 3, x plus 3 in either order. So the x values of the equation are
0, 3, and -3.
0, 3, and -3. Okay, and now time out. Remember, these equations also have y's. So we have two shapes. We have some kind of cube thing, and we have a line, and they're intersecting in 3 points. So one of the points is 0, comma, one of them's 3, comma, and one of them's -3, comma. So what do we do to get the y part of the points? We have the x parts. Fill it in. So I'll put it in right here, it's easiest. If I put in 0, I get 0. 3 gives me 9, and -3 gives me -9. So there's the solution. Is everybody okay with that?
So it's that whole set is the answer?
Pardon me?
That whole set is the answer?
This is the answer. Yep. There are 3 points of
So
intersection.
if we get a question like this, we're supposed to solve for the whole coordinate.
Absolutely. Remember, the one, like, think of the ones we did yesterday. They were things like this. And we only concerned ourselves with the x's, because the only thing up here is x's. Okay? All right, what's the next one? That seems very easy. All right, ooh, solve graphically. All right, so now we need our calculators. You boogered up the window. I zoomed 6. I don't know what would happen with the window we had, but I'm going to zoom 6. And all that does is bring me back to a standard window. And then I'm going to put in my equations. So ln, that's your natural logarithm function. So just ln and then x. And then x squared minus 4x. ln is in the column over here.
We have to close the parentheses.
I don't believe you have to, but I always do. I don't think you have to. Did you get something that looks like something like this. So the answer to the question, we want to know, where do these things intersect? The answer will be right there and right here, right? So you know how to do that. Second calc intersect. Okay. Now, be careful, you need both coordinates. I got one point of intersection, B, 0.712, comma, negative 0.340. Good. You guys are faster than me. Everything, I'm sure.
Not all of us, just guys.
And the other one is 3.828, comma, 1.342. You okay with that? Now, you guys need to have a little bit of sense of appreciation for your old lady teacher. That hasn't changed, right?
Yeah.
It's the same, it is what it is. But when I was your age taking this class, we not only didn't have a graphing calculator, we didn't have a calculator. And we had to do all the things that you're doing. So imagine if you had to solve something like that without a calculator. Now,
How do you do that?
I don't know if you would consider it good news or bad news, but, let's see if it's over here. Oh, yeah. So instead of a calculator, we all had to buy what was called the CRC table. So you know how you press on your calculator, square root of 2, and up it comes? Well, this thing is full of numbers. Every number, look at that, right there. Let's see what that is. That's the natural trigonometric function,
How
it's
do
the
you,
5
like,
places.
how do they find
So
that
when
out?
you press sine 20 and up it comes, I got out my trusty book and I looked up sine 20. And then I had to do the addition and the multiplication, whatever was going on by hand, because we didn't even have a scientific calculator. Isn't that amazing? I mean, think about it, before you start whining, before you start whining about how hard you got it,
Before, did you ever have to teach with no calculator?
remember, no.
They had them by then.
Did that make you
yes.
really angry when you
They,
had to
I
teach?
actually, my first calculator, actually not mine, my husband's first calculator, he's an engineer. His first calculator that he got for college is in the display case down there. And it had so little, first of all, you had to plug it into the wall. And second of all, it had so little functionality compared to what you have, and it was $300. And compared to what you have, I mean, it had.
$300 an hour back then.
Back then, it was.
Now,
So that's like a
yeah,
that's
it's like $1,000 calculator.
At least.
So,
They can translate currency dollars.
But you have to do it.
you know, when your parents say that they had to walk to school uphill both ways and all that stuff, really things were different back then. Your parents are younger than me, but your grandparents, it was a whole different world.
That's a good question, though. But no, did you have graph paper back then? Okay.
I was like,
And
you
we
lived
used
in
it
Ohio.
How would you, like, would you guys not graph equations like that then? Like, so
No, we wouldn't, we would have to use all kinds of our numbers and approximations. So, like, this guy right here, I mean, so you start plugging in numbers, but with LN, this would be in a table, I could find that. This I would have to do by hand, and you start plugging in numbers and just trying to get as close as you can. We use the process called interpolation, which actually I did teach when I first started teaching. We all taught the process of interpolation, where it's like you've got two table values and you kind of squeeze in on the one you want. We don't teach that anymore. It's a cool thing, but you don't need it. So, yeah, there's lots of things we don't
That's
teach
crazy.
anymore. It is crazy. All right, solve algebraically. Here we go. This one's easy. Even back in the day, this one was easy.
Yes, I can.
Yeah.
How do you want to solve this?
Elimination.
Elimination. Happens to be my favorite too. I love to eliminate. So let's see, I'm gonna need to multiply maybe this one by 3 and this one by 2. You got choices, it doesn't matter.
What do you mean with it?
Keep an eye on my arithmetic. Oh lordy. 57, I got negative 57 for y. Double check, did I do that wrong?
Yeah,
What you got? What's the positive?
The 10 should be a positive.
Thank you, that makes a big difference, thank you. And that's gonna make this 3. Okay, that's happier, thank you so much. Okay, now we'll take that 3 and plug it back in somewhere. Did you get negative 2? And then we'll answer as an ordered pair, because always, 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 we are looking for where these two lines cross, and they're gonna cross in a point, right? All right, do B. Quickly, let's get B done.
On delay.
Looks like the same problem, kind of problem. Okay, can I make another one? I didn't get it all to cancel. I got 0 equals 8. What does that mean? It means they don't cross, which means these two lines must be parallel lines. These are lines in standard form. We have parallel lines, so our solution is none. They don't cross. Parallel lines don't cross. All right, I think we can finish the last one. Now, assuming I didn't make another arithmetic mistake, did you get everything to cancel?
Yes.
Okay. Now, that is not no solution. Quite to the contrary. What is it?
Everything is all real.
Okay, now, all reals would be wrong. Okay, that would be wrong. Because remember, what are we looking for? Where do they cross? Right?
Everywhere.
Now, not everywhere.
Nowhere.
If these are my lines right here, they don't cross up here. They don't cross down here. They cross on this set of points, right? So our solution is all of the ordered pairs that satisfy either one of the equations. It doesn't matter which one you write down, I'll put the simplest one. So in other words, if you are an ordered pair on this line, then you're part of the solution. Does that make sense to you? If you say all real numbers, you're talking about the entire plane. And that is not the answer. The answer is these points right here. And those are the points on that line. That's your answer. So they're infinitely many solutions, that's for sure.
Okay.
But they're on this one. That's your answer, yep. And I used the little line, you could have used the other four double lines.
So we can choose either one of those original.
Right, quiet.